Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So here's a lot of people involved in our group in DCU who have become interested in SenseCam projects and doing things with the SenseCams that we got a couple of months ago. There's a group of us who are faculty, group of postdocs, group of PhD students, master's students and summer students, and that's not because Microsoft money stretches very far and covers all of these people, or that we are very cheap. It's just that we have a large group of people who do image and video analysis, and when we got these devices, we almost have to book them amongst ourselves in order to get access to them, because so many people in our group do things that they want to try out on SenseCams. So, an overview of the presentation is I'm going to talk about what specifically our background that we might bring to the SenseCam project or set of activities is. And then I'm going to show you 5 things that we're doing, have done, or are planning to do with SenseCam data. Our contribution is that what we do is we do image and video analysis, and we do indexing of video and images and summarization. And we apply this and are applying this to SenseCam data, and that's why there's so many people listed on the front slide. We don't have any particular SenseCam application, unlike most people in the room. And what we do is we develop what we would call underlying technology or facilitating technology. And we're keen to hear about the real problems that real SenseCam users have in the real world and seeing how they can steer and give us guidance for the kind of technology and underlying analysis that we do. Another thing that we see as a difference between what we're doing and many of you are doing is that we consider the typical full-day SenseCam images, in other words, the full set of 3,000 images gathered in a day, and we do event segmentation and summarization, where some of the applicants, or some of the applications here are just dealing with session-based recording of activities. We've been targeting in the few months we've been working with the data the full day, in other words, from the moment you wake up to the moment you go to sleep. The first problem we tackled was that when we recorded the day SenseCam images and then we looked at the 3 or 4 minute movie, it's great, okay, and then the second day it's great, but it does your head in sometimes because it requires a lot of concentration. So our approach is to take the 3,000 or 4,000 images of a given day and to segment them into what we would call events. So finishing work in the lab, being at the bus stop, chatting somebody in a hotel, moving to a room, etc., etc. Segment my day's activities into individual events. And if I can do that, then what I should be able to do is detect and pull out a number of frames from this one, a number of frames from this, maybe a lot of frames from this one because it's an unusual one and it represented a large part of the day, and so on, to build up a composite and a summary. And what the movie that we watch as the summary of SenseCam images does is it just regularly time slices these. We would like to try and generate summaries in a more informed, event-based approach. Automatic event segmentation, the first of the 5 topics that we'll talk about. The task is to automatically determine events from a collection of SenseCam images from an entire day. And our approach is based around doing image-image similarity using low-level MPEG-7 features, where the differences between sets of images may indicate a transition from one event to another. It is very similar, in fact it is almost identical problem to the shot boundary detection in moving video, but it is much more challenging with SenseCam data because the SenseCam images, as we know, have a more of a fisheye view, and there's also a lesser degree of similarities between the individual SenseCam images in an event than there are between the frames in a video shot. Several approaches can be taken, and here are some of them, okay, that we'll go through. But first of all, is a couple of SenseCam images. What we do is we take the first one, we pull out MPEG features, like things like scalable color, color layout, color moments, and edge histograms and texture stuff. We do the same for another SenseCam image. We combine them together and we get a similarity value between them. Now, you look at those 2 images and you say, well, it's the desk, and it's just a different view from the desk because the wearer may have turned slightly to the right or to the left. And these sets of low-level features should be invariant to those kind of movements. So, take a single day's images and extract for every image all of the low-level features, or a subset of low-level features from the MPEG-7 toolkit. and in order to compare similarity. And then compare similarity between adjacent images and generate a kind of a graph and see where the big changes are. Now, that works fine for video, except that for SenseCam images, if this is an event in my day, my presentation, and I'm wearing one, then this is one picture and this is another picture. And they're very different in terms of some of those low-level characteristics because I move constantly during the event. So what we do is we compare similarity between adjacent SenseCam images, between pairwise distant ones, and so on up to some distance away. Okay? So there's a lot of similarity computation that can be done in this, but there's ways to improve it and make it feasible. And then what we do is we take all of those similarity different values, fuse them in some way, and we get some sort of segmentation of the day into events. Okay? Now the reason why this approach should work is that in the top there, what we have is the ideal world, where here, the first case, we have the brown houses, which represent one event, and then we have the green trees, which represent another event, and there's a hard cut between them. But in practice, what happens is that we get rogue images, which look very like some other event, but because they're placed in the current event, they can trigger false positives. So that's why we have this near-wise comparison, and also this distance-wise comparison in terms of the adjacency of images. Some preliminary results, it's kind of anecdotal. We've taken a fair amount of data and we've manually annotated into segments. So here's one day, there's 2,685 individual pictures, manually detected 27 logical events. And if we use color moments, then 14 of them are segmented correctly. Using edge histograms, 15, other features you see 17 and 18, but they're all different. And the future work in that area is that there's lots of work to be done, including the obvious one of fusing together the descriptors from each of the MPEG features, and also optimizing the windowing distance on which we do that comparison. Second approach to event segmentation is to use similarity clustering and time, the temporal constraint. And this is based around combining low-level content analysis, the same kind of stuff in the first approach, as well as metadata provided by the SenseCam and temporal data as well, in other words, the time of day. We generate a similarity matrix for the entire day by fusing together the low-level and the metadata information, and then we implement time constraints to constrain the clustering in some way. And this is what it looks like. So you take a day's SenseCam images. As before, you extract all of the low-level features for each one. You then combine in the metadata from the SenseCam, things like light and temperature and accelerometer, and GPS data if you have that available. And you generate a large similarity matrix of the SenseCam images for the day. You then apply some temporal constraints to do some clustering, and then from that you generate a hierarchy. And basically you can threshold up and down that hierarchy to get different levels of event segmentation. So you go in there, it divides it up into 2. You go down further with a lower threshold, it divides it up into 4, and so on, like this. And this gives you methods for doing segmentation. And we don't have numeric results for this. We've got anecdotal results on some of the images from a couple of wearers, and we find that, anecdotally it seems to work well, but we have to put it to the hard test of doing real comparison and generate precision and recall figures. The third approach to event segmentation is to group images into 3 classes, where the 3 classes represent a static person, okay, which is me. Even though I'm turning slightly and I'm moving around a bit, I'm still a static person, okay. The second one is a moving person, which is somebody on the move from one location to another. And the third one is a static camera, which is like this one here, which we found many of us do actually when we wear the SenseCam, is that we'll actually just take it off and just put it there, okay, to record the event. And if you've been using this, you know exactly what I mean by each of these. The approach we've taken for this is that we do block-based cross-correlation between SenseCam images. We also generate spatiogram image color similarities between SenseCam images, and we look at accelerometer motion values. So this is a kind of a training approach. It uses a Bayesian approach to training, and then we smooth out all of the output of that using a Viterbi algorithm. How does it look like? The same diagram again. Previously, you take a day's SenseCam images. For adjacent images, you calculate block-based cross-correlation between adjacent ones. And you do spatiogram similarity, right, which is spatiogram similarity is like a fuzzy blur of color that can appear anywhere in the image. And this kind of it takes into account for me taking a picture here and then me moving slightly. So in the image, the most dominant color might be somebody's shirt, okay, and it might be slightly different space within the overall image from between adjacent images. Well, the spatiogram can address this. We then combine that with accelerometer motion in order to classify each of the SenseCam images into one of the three classes, and then we apply some smoothing to get activities based on the motion of the SenseCam. Okay? Some anecdotal evidence of this again. We have some sort of single-day analysis done, but you can see this corresponds to the wearer actually being on the move, and this corresponds to being a static person. And you can imagine if the SenseCam is fixed, then it's going to be flat-lining down the bottom in terms of accelerometer motion. So it seems to work pretty well. Okay, the second thing that we're addressing is generation of weekly summaries. So let's suppose we've taken the day's SenseCam images and suppose we've segmented into the 20 or 30 or whatever number of events. What can we use those events for in terms of providing some sort of navigation through this? Well, the way we do this is that we calculate the average values for these events of the low-level features from all of the constituent images for that event. We then generate a similarity matrix, not of individual images, but of events. So you might have a 20 by 20 or a 30 by 30 similarity for each event. So you're dealing with events rather than individual images. And we find that visually similar events across the day or across many days can then be detected. And the time period or the week can perhaps be structured automatically into, for example, a short movie. Now, why have a movie week? And we confess that when we looked at beyond the event segmentation problem, we were saying, well, what can we do with this? Where's the application we want for this? And we were very inspired by Georgina's presentation when we went to visit the NSR team in Cambridge, and she gave us an abbreviated version of the presentation that we saw earlier on this morning. And in that, what they do is they give a one-week summary, a rolling one-week summary. So today I get the last 7 days, tomorrow I get the next 7 days, and so on. So we thought, let's try and do that, and let's try and do it in some way that uses the events in a semi-intelligent way. So what does this look like? Again, this is 7 days of SenseCam images, and they have been, by some process, like the ones I've described earlier, segmented into individual events. What happens is we take all of the maybe a couple of hundred events that exist for that week, and we generate event-to-event similarity, okay, using this large similarity matrix by comparing for every event all of the constituent images for that. And we find that there's a lot of similarity between these. I don't know if you can make it out. There's a kind of a light blue colour, okay, which correspond to repeated events that you might have during the week. You go to the same workplace, you go to the same restaurant for lunch, and you eat breakfast in the same kitchen, so you'll find that there's a lot of visual similarity between that event as it reoccurs. Okay, there'll be other events like these, and this probably doesn't come out. Yeah, okay. The yellow events correspond to another regularly occurring event throughout that block or that mass of 1 week's events, and another regularly occurring event, maybe watching TV or something like that. And then we'll find that there are outlier events which are visually very dissimilar to the rest. These correspond to these bright colours here. So what you get at the end of all of this process is that you get some indication of which kind of events are repeatedly occurring, like the pink event and the beige event and the blue event, and which events like this red and blue and green and purple are outliers or unusual ones, or maybe they would be landmarks in my week. Okay? What we then do for that is that we generate for that week an equivalent of a movie, except rather than just regularly time slicing, we take the outlier events and we give them more space. Why? Because they're outlier events. And I don't need to be re-prompted about, I had breakfast again. I had breakfast again. It was the same as yesterday, and it'll be the same as tomorrow. So I reduce the amount of time given for that in the generated movie. But this red event, whatever it might be, very dissimilar to anything else I've done in the week, and it gets a large time slice in the generated movie. And then we repeat the process for the next day. John?
Can you focus just on meal time? So if you want to do nutritional studies and the person just wasn't able to log what they were eating, you could focus only on times that were identical, like breakfast, lunch, and dinner?
Yeah, so in this case, we're highlighting the outlier events. I mean, it's a line of code to do it the other way around. I confess when we were doing this, I only want to see the outlier events and for a different application. And remember I said at the beginning, we're not biased to any particular application. We're just doing stuff, technology. We want to be driven by those kind of applications. So yes. So while I present it this way, it could be the other way. It could be all beige, right? Careful choice of colors here, right? So what we do is we generate for the next day, and the next day, and the next day. And as you generate from day to day, what tends to happen, and you'll notice it I think if I just go one more slide, yeah, one more slide here, is that in this particular configuration, the red event, when it occurred here, right, at first it got a big blob of stuff. That's a different red event, okay? And as it moves from day to day more forward, right, its size starts to decrease, perhaps, okay, because it becomes less significant because it was 2 days ago and then it was 3 days ago and 4 days ago. But again, you could reverse it and you could highlight it even more so. Depends upon how you want to configure this. So we did some preliminary results on this, just to, well, how do you evaluate that kind of thing? It's very, very difficult. So we took a week, okay, and we segmented into several hundred events. And what we did was we took a sample of these 10 events, and we take, let's say, lunch at the work, right? We take one event called lunch at work, and we run it as a query against all of the tens of thousands of other SenseCam images. And we pull out the top 10 of those. And we find that of those 10 that are retrieved, I've actually chosen a bad example, haven't I? Let's choose this one here, at the coffee machine. So I use that event, which occurred once during the week, and I pull out 10 images from the thousands or tens of thousands, and I find of them, 6 are actually other events, or correspond to other instances of me being at coffee when I use color layout, or when I use color, scalable color, it's this, or when I use this feature, it's other ones. So what we can get from this is that things like edge histograms are very good for clustering things like working in the office, because my office is full of books and shelves and very strict furniture, right, sharp lines, okay? So different features work well for different kinds of things. Face detection and body patch matching. This third piece of work we were doing is to apply face detection software to detect the presence of a face in a SenseCam image. But we augment this with body patch matching, and we've got other projects which have indicated that this works well for personal photos, but the quality of personal photos is much better than with SenseCams, because SenseCams are of lower quality. So what we want to do is detect that, but detect the face by saying, okay, this is an indication of Aiden, and we've got a good face grab, but we use the body patch matching to indicate perhaps another fuzzy indication of Aiden, but we indicate, or we get a good clue as to the fact that there's a face there based on the fact that the body patch underneath the face is there. We've used some data that Harry has given us from Arizona that he described earlier on. They gave us some SenseCam data a couple of weeks ago. As I said, it's session-based rather than all day. We've applied our event detection stuff to it using the low-level features. It doesn't work terribly well. We've applied the face detection approach that we've described earlier, but it doesn't work particularly well because we tend to get, as we all do with SenseCam images, blurred images, which cause the standard face detection software to fail. But what we think we could do is alter the algorithm that's used to trigger the photo taking, so that, you know, we will grab an image when there's less blurring and perhaps when there's zero motion, and we might be able to address this. We did some analysis of it, and we found not great performance for the different kind of features. Another project, or another activity that some of the people in our group are doing, is that we're logging Bluetooth devices. So a SenseCam wearer will also carry a Bluetooth-enabled phone, and that will basically poll every few seconds to see other Bluetooth phones in the area, and this would give an indication of the people who carry those phones. So you need to know about the other people, your colleagues and friends, etc., would have Bluetooth phones, and basically logging it on the phone. May be useful in determining which individuals are present around each picture, and we've developed that application. We're trying to synchronize that with images. We're also looking at, as many other people in the room will be, looking at other data collected from GPS and body media, heart rate monitor, and correlating those with SenseCam images. Last topic, and this is about presenting SenseCam images as a movie. If we want to present a summary, whether it's a flat summary or even an intelligent-based summary of one day's playback of SenseCam, then this is not perhaps an ideal interaction because it requires intensive concentration. The event boundaries cannot be clearly presented because they just go by in a blur. And the sense of time tends to be skewed, especially if we start to do the time warping as we generate these variable width summaries, so that that requires a lot of cognitive effort on the part of the viewer to watch this movie. Well, we're looking at turning the sequential playback into an interactive spatial browsing interaction, in the same way that what we do is when we view video is that we view keyframes for that video. And the way it would work is this. What we generate for every day is a one-page visual summary with each image, like a keyframe, representing an event. Remember, we assume that we've segmented the day into 20 or whatever number of events. And the size of the image, in terms of footprint size there, represents the importance or the uniqueness, or maybe the reverse of that, of the event. And the timeline on the top of that orients the user about the time dimension and when each event happens, and using a mouse over, it activates those. So basically, this is the most unique event of the day. These are quite unique, and these are the regular things that happen in the day. And if I mouse over that, then what happens is I get a pop-up indicating what part of the day that occurred in. If I basically mouse over other ones, I get similar ones. So mouse over will start the playback of that event within that mini window, and also indicate the temporal area in which that occurs. Similarly, mouse over this, and I get playback. Mouse over this, and I get playback within that little window. So this, we believe, could give a more easily absorbed summary of the day by presenting and showing the difference between the different events in terms of their importance or not, as well as giving where they occurred throughout the day. Okay. Hypothesis is that it's a more relaxed, interactive, inviting summary. It may not be appropriate for all applications, but for those people who just gather SenseCam images and store them there for the sake of having them, and then to allow subsequent browsing of them, rather than using them as a memory aid, it might be a more natural way to browse through those images. Playing each of the events in their location might also be good, and the importance is not by playing more images in that event, but by having a larger image on the playback. We've written 3 papers describing some of these things, which are all in the submission stage. One of them was submitted to the ECHISE workshop associated with the Ubicom event that Georgina's paper has been presented at. The other one was for CARPE, and another one is for the SPI Electronic Imaging conference in January. And these give more details of this stuff I've blurred through. And if anybody wants any details of this, I'll be happy to give you the submitted versions of these papers. Future work, we basically want to do all of those kind of things. Okay?